Okay, how are you? No? So I have to introduce on how to solve an ordinary differential equation first order, first degree. Okay? So we have methods of solving a differential equation in first order, first degree. And one of which is the variable separation. Okay? That's applicable if the dA is classified as a variable separable differential equation. Now, when can we say that the dA is a variable separable dA? Now, if we consider writing a differential equation in a differential form, so this is the general form of a first order, first degree dA. Okay? So notice that the coefficient of the dx are functions or is a function that is involving x and y. So with the coefficient of the dy, this is also containing x and y. Now, it is classified as a Vsde if these coefficients of the dx and the dy are functions which can be expressed in a factored form where the factors involved are purely x and purely y function. So with your n, so it is function in y and function in x. Okay, so dapat factorable siya. And the factors involved are purely x and purely y. So if we apply that to the given dA, and I'm writing my dA in a factored form, okay, so I can easily separate my variable. So if I have to look at the variable involved in my differential, so this is x. So in order to integrate later, the coefficient of your dx must be a function that is purely x. So if that is the case, then I have to remove a function which is not in x. So like the f of y. So we can easily remove that if we divide with f of y. So if I go also to the second term, the dy term, so this is also associated with a function which is involving x. So I can also remove the g of x by dividing with g of x. Okay, so this is now the manipulation to separate my variables. Okay, so checking on the variable in my differential, this is x. So I have to remove the f of y. So I can divide with f of y or multiply with the reciprocal of that function. So this is dy. So g of x must be removed. So 1 over g of x is provided. And if that is distributed, then I form a new equation wherein I'm already separating the function in x and function in y. Okay, so I can now proceed with the integration. So the f of x, g of x is a function in x. Then these are now integrable term. So after you do the integration, then you arrive with what we call as the general solution. Okay? Now, if you are asked to give the general solution of the differential equation, okay, so my solution is, okay, I have to rewrite my dE to follow with the general form of a first order, first degree dE. Okay, so 2xy, y prime is dy dx or dy over dx, because if I'm going to multiply with the dx, then the dx can be associated with the 1 plus y squared. 1 plus y squared times the dx, then I take the term, the 2xy dy, associated with dx term, so minus 2xy dy equal to 0. Now, checking on the coefficient of the dx, so there is a function which is purely y. So this is not supposed to be here. And if I'm going to go with the dy, well, this is y, this is associated with x. So how to manipulate separating my functions. Okay? So I can remove the function 1 plus y squared by dividing it by the same expression. Okay? Unya kini, I also have to remove the 1 over x. So do not let your 2 be associated with x. So have your 2 be associated with y. Okay. This is now the resulting equation where functions in x is associated with the dx, function in y is also associated with the dy. So you can now proceed with their integrals. And you have to look on the formula of integration applicable. So this is on time. If this is my u, you notice that this is also a du. So u is x and my du is the dx. So there is u and a du form. So you can relate that with the formula of integration. The differential of u over u is equal to integral of the differential u over u, which is equal to L in u plus c. Okay? Now, integrate your first term, so using that formula. In my second term, ang akong to ganina wala na ko ibutang outside the integral sign because I already observed that my denominator is quadratic. And if I'm going to call this as u, ang aton dio will involve 2y dy. So sa ato pa, 2 is part of the exact differential of this function. And this is, again, following a formula like this. No? So we have u and a du. So I'll be using the same formula for both. No? So we have ln u. So ln x minus the ln, no, of y, 1 plus y squared. So just put 1c because the integral of 0 is c. So for the constant in every term there, ato lang imutangag usa ka constant at the right side. Now, in the presence of an arbitrary constant, the solution can be classified as a general solution. Now, if we notice also, we have two logarithmic terms. And if these are two logarithmic terms, we have property of logarithm where we can write it as 1. As a difference, we can have a ratio of x over the 1 plus y squared. So, I have a logarithmic term and this is, this is c. Okay? So, we can also write it in terms of an exponential to remove the ln. Exponential c remains to be an arbitrary. So, you can also call that as c. Okay, what is the exponential of ln x? So, we have different properties of logarithms. At the same time, we also have laws of exponents. No? Now, the property I'm using is actually where? Kini. I have a difference of two logarithmic term. They have the same basis. Then we can have a ratio, x over y. So, unang ako gibutang x over this expression. So, I'm following this one. Now, with this part, if this is ln, the base of my ln is e. So, if I have e ln x, this form, then this can be x. So, if I'm going to put this, no, as an exponential function, so expressing that as an exponential form both sides, no? So, we have the exponential of ln. Okay? So, kini, mugawas ni siya nga unsa this expression. Okay? So, to simplify, okay, so exponential of ln of my function, and we have an exponential c. But the exponential c, no, if an arbitrary constant is operated with other constant, then the nature of which being an arbitrary remains to be an arbitrary. So I can still call that as c. Okay? So, this is now the simplified form. Removing my denominator. Okay? So, by multiplying with the LCD, then I can obtain this one. But if I'm going to divide with c both sides, then there is 1 over c times x. And again, that is an operation involving an arbitrary. The 1 over c can also be called as c. Okay? So, you can have your answer that way. So, bisag asaan ng tulo, puros na sakto. Okay? Now, how to do the checking of answers? Na? Ngayon. If we have to check our work, na? So, you do it this way. Eliminate your constant. So, there is a solution there where c is isolated. So, ako na lang i-isolate. And do the differentiation with respect to x, no? And then, by formula, under a quotient rule, so, we come up with this, square of the denominator, no? So, this is following the quotient rule. Then, I remove my denominator. So, I come up with this equation. I try to rewrite that. Then, I arrive with a given dA. So, it means that my answer ganina is also correct. Okay? So, be familiar with the rules of differentiation. Now, another problem, actually, ingana rin ang sequence na ito pag-solve, no? So, you can recall here the formula of integration dealing with trigo function also, and some identities maybe. Okay, this is x, but this is associated with y. This is y, and that's dy, so this is okay. So, there's a little problem with the first term. So, in factored form naman siya daan, so ako na lang i-remove ang cosine squared, I can divide every term by the cosine squared. And this is the result after dividing, and after separating my variable, I can now proceed with the integral. Okay? So, this follows the formula, kine. Maybe we have to consider if tangent will be considered as our u. Unsa man kay du? The du of tangent is the secant squared u, du. Okay, so the differential of tangent u I mean. And the 1 over cosine, the reciprocal identity, the 1 over cosine can also be secant. And 1 over secant is also equal to cosine theta. So, tangent must be paired with a secant squared if we have to let our tangent be our u. The secant squared u is part of its differential. Okay, so I'm rewriting my equation as this, x dx, and I have integral of tangent y, secant squared y dy. Because if my u here is tangent y, my du is secant squared y dy. So, this is now taking a form of u du. So, it is the power rule of integration which is applicable. So, the same formula in this is u to power n and a du. So, I'm now increasing the exponent by by 1, no? Squared over 2, no? X squared over 2, tangent squared over 2, that's equal to c. Removing your 2 here, so that is twice c, but that can still be called a c. So, that is the answer, x squared plus tangent squared y equal to c. And again, by checking, so I can take the derivative, both sides of my equation, no? To eliminate my c, okay? So, 2x for the x squared, tangent squared, power rule sa ka, 2 tangent y, derivative of tangent is secant squared y becomes y prime, this is 0. Okay? Removing your secant squared, no? Because I want to go back to the given dA, if possible, no? Okay, ngini. So, x over secant squared, as I divide, no? 2 is also eliminated, so kung i-appeal pag divide. Then, I have the tangent y, no? dy dx, okay? Removing your dx, and 1 over secant squared can also be cosine squared. So, I arrive with a given dA. So, it shows that my answer is really correct. Now, in number 3, doon ay problema gamay because the coefficient is not expressed in factored form yet. So, we have to apply factoring. Notice that my x here is common. So, I apply factoring first. No? Common monomial factor from the first term. In the second term, we have several terms involved. So, I can apply grouping of terms. Okay? To check, no? So, doon ay common factor between these two. Okay, and I'm going to remove the x squared. You will notice that the resulting factors are, no? One of which is also the secant term, no? In the secant grouping, no? Okay, so, that is how I did, no? X out. Okay, x squared is also factored out from this. Then, kine, again, na common factor. Pariho na good ini. If my common factor ganina is x squared, ako gi-remove. The common factor here is y squared plus 1. That can also be removed. So, divide. If this x squared is not yet included, so ato sa ibutang sa secant factor. Then, I have 1 from the y squared plus 1 which is left. Okay? So, purely x, purely y, purely y, purely x. So, we can separate the variable x. So, okay lang na rin, kini mo yung tangon. Kine, y, and that is also dy. So, I have to remove that one. So, this is now the result, no? When the variables are separated, okay? I remove that one by dividing. I remove the x squared plus 1 by also dividing with the same expression. Then, I have the resulting, okay, term cell. Okay, and then, no? We have to consider the formula. D over U, quadratic and linear. But this one, in working with fraction, and that is improper, so do not consider a formula. But instead, consider division of polynomial before you can integrate this. So, I have to divide. I'm using synthetic because this is just a linear divisor, or you can divide by by long division process if you like, no? Okay, so gana akong synthetic. Okay, so after dividing, okay, so gana mo akong quotient, no? So 1 down, multiply, go with the next column and add, no? So that's the process in the synthetic division. Okay? So my quotient is y minus 1 for my quotient. That's the remainder 2. Okay? Malibo gani ka synthetic division. So just recall your long division process of division, no? Okay, so first term, du over u. This is lacking with constant to. I can insert the lacking constant provided that the lacking expression only a constant is needed. Okay? Or the coefficient, no, of your differential or your differential, no, only lacks a constant value. Okay, so to may kuha, I neutralize with 1/2. Kine, this is now the resulting integrand after it is divided. Okay? Then I can consider a formula. I take them as a group na lang. Actually, pwede sa gamay yung y squared over 2 minus y. So, ako na lang nang ikausa. So, y squared, 1 minus y minus 1, then square over 2. Then, I have minus 2. That's d over u. So, minus 2 ln u. Now, I have to remove the denominator to. I have to simplify. Okay? So, by multiplying with 2. And I separate the term with no logarithms, no, or ln, notations, no. So, akong i-group ang mga ln. Okay? Now, if these are two logarithmic term, pwede na nako makombine as one, but this as 1 una. So I make my 4 as an exponent. Difference, then I form a ratio. And I have sim plus, no? Ako man nag-transpose as naman daw. Okay? So that is transpose, no? It becomes positive. Then, I can make it, no? Ako si mo on nga exponential para mawa ang ln. Okay? Exponential function both sides, no? Or exponential notation both sides, no? In order to come up with this as the simplified form. Okay? But for this, saan na to? We can apply the law of exponent. Okay? Look at this way. Look at the simplification. This is already the simplified form. Now, if I have a to power m factors, no? Okay, so a to power n. That is good as a to power m plus n. Now, what I have here is the sum of two functions. So, I consider this, no, separated in terms of factors, no, a common base of e. So I have an exponential c times. So this is now multiplied with another exponential of y minus or y as the exponential of the square of y minus 1. Okay? So exponential c remains to be an arbitrary. You are free to call that as c. Okay? Then you remove the denominator, you multiply that. So x squared plus 1. So, c times, asa man, kini. Then, kining, exponential nimo can also be written as this. Exponential, then, down na lang na. So, y minus 1 squared. Okay, so that's the answer. Now, number 4, it takes similar form as this. So, di na tamo problema ini. Y prime is equal to, x with exponential, y minus x squared. Now, the kind of solution we are after here, no, is a particular solution. So, if it is a particular solution, then after the general solution, you have to consider the boundary condition to solve for the value of c. Y prime is a dy dx, correct? Okay? So, in the same notation ganina, na, exponential, my function is y minus x squared, no? Okay, so the x term, dy term, okay, equal to 0. I cannot integrate y because x and y still part of the coefficient of the dx. So, I have to apply factoring by using this law of exponents. No? Pareho ganina kung gigamit. No? Okay, now, in factored form, no? Okay? Then, I can separate my variable, no? So, ang buwag ini, kanira exponential y. So, that will be removed, no? I multiply with an exponential of minus y to remove this, or pwede sa kung mag-divide. So, this is now exponential minus y. I have my u here, which is kine. And my du is this one. This is lacking with minus 2. Later, it can be provided and neutralized with negative 1/2. My u here in the second term is minus y. Okay, so my du is minus dy. So, kuwangag minus y. Minus 1, I mean. Then, dire, kuwangan sa dugod sa minus 2. Okay, so provided with minus 2, provided with minus 1, neutralizing factor are also considered. And then, I do the integration in what form? Exponential u du, exponential u, exponential u, the same formula. Then, converting the exponent as positive. Now, ganun. So, I love to apply the law of exponent, reciprocal, para mahimo siya nga positive power. Okay? Then, mao na naimuhang general solution. Pero as I've said, itamuhunog general, kay nga naman, naa pa man tayo gitawag conditions, no? Para makasolve ta sa C. So, I'll be solving for C by substituting x equal to 0. So, your curve will pass through where? Magi sa origin. Okay? So, 0, 1/2, negative. This is 1. Now, exponential 0, or any number is to 0 is 1. When this is 1. C is equal to 1/2. Substitute to the general solution. Okay? So, this can be an answer if no required form is indicated. However, express your answer in a way that y will be expressed in terms of x. Okay? So, this is how the simplification works. No? Exponential. I have 1 over. So, I'm considering a term with y. Okay? Ang walay y akong ibalhin sa lain nga side. Okay? Mao na akong i-transpose. No? Which is kini. Combining them as one fraction, I take the LCD. Okay? Divide with 2. Okay? Then, we can rewrite, no? Light way. Anya, we take the reciprocal of this para I can have the exponential y also. Exponential y is equal to the reciprocal of the ratio. 2 times, this is written again, back to the given, exponential x squared. Okay? Now, para ma-solve nimo imong y, then you can take ln of exponential y, which is y. ln of this cannot be simplified anymore, so this is now your answer. Okay? Now, before mo ko, na, we have two types of solution here nga atong nasugatan. We have a general or complete solution, a solution containing at least one arbitrary constant, which represents the equation of the family of curve. This is a kind of solution known as a particular solution after solving for the value of c in the general solution. No? This solution represents the equation of a specific member of the family of curves. Okay? So, that's all I can share in the variable separable dA. Okay? So, for now, so thank you for watching and until the next topic that I'm going to share. Okay? So, bye-bye.